Our own galaxy, the Milky Way, is moving toward our neighbor, Andromeda. Both galaxies are spiral in shape, but Andromeda is about twice as massive, with a supermassive black hole, the mass of 30 million suns.
It'll look a lot like a dance. And you see the two galaxies come close together, so they kind of dance around each other, getting closer and closer and moving faster and faster before they finally come together.
But at the point of impact, these galactic dancers will do more than pirouette.
Each one has a spiral disk of stars, and then surrounding that, a halo of dark matter, invisible material that we can detect by its gravitational field. These two dark halos, which are much larger, will overlap as the galaxies pass by. Eventually, as the two galaxies spiral around each other closer and closer, you can no longer distinguish them as separate systems, and finally the nuclei merge.
When Andromeda and the Milky Way collide, that's going to be the biggest collision that the Milky Way has seen, something like 5 billion years' time. The good news is that we, the solar system, will have a grandstand view. What will happen is that two galaxies, their spiral disks, are going to get tidally torn apart into fantastical shapes.
When the disks start to get close to each other, they'll throw off long streamers of stars, so-called tidal tails. And what happens to the sun and the solar system, should we still be around, it really is hard to predict. We could get lucky and be on one of those tidal tails and get a sort of bird's eye view of the whole process as we fly out. Or we could get thrown into an orbit plunging towards the center of the merging galaxies. There's basically no way to say.
During the merger, if our solar system moves through the suburbs or the edges of Andromeda, we might not notice anything. On the other hand, countless stars and space material could be propelled towards the planets, potentially disrupting their orbits around the sun. Moreover, the entire galaxy could face cosmic upheaval.
We could have consequences which would nonetheless be dangerous. First of all, we could have a lot of star formation as a consequence of the merger. Currently, both the Milky Way and Andromeda galaxy have plenty of interstellar gas, the raw material from which stars are born. Now that would mean a lot more evolved stars, supernovae, going off in our vicinity. And that could create shock waves, blast waves, bursts of cosmic rays, which would have nasty consequences.
After the merger, the fate of our solar system is uncertain, as the supermassive black holes of Andromeda and the Milky Way vie for power in the newly jumbled galaxy.
When they merge, they're going to form a new galaxy, and these two supermassive black holes will gradually spiral into the middle of the new galaxy. They will be a binary black hole for a short time.
And these black holes will start to swallow gas as the collision stirs things up. Gas will fall into those black holes. They're going to turn on. They're going to start emitting radiation. But the potential for fireworks, possibly for fueling the black holes at the centers of the galaxies, matter falling into them, possibilities like that do exist. And then the only safe place to watch the process would be on one of those tidal tails riding out and escaping the collision.
Some scientists think that Andromeda's larger supermassive black hole will eventually consume the Milky Ways.
The two black holes will spiral in the center and become a binary black hole, and ultimately will merge with one another to become yet an even bigger supermassive black hole.
So a small galaxy colliding with a large galaxy is likely to be dominated by the larger galaxy. It'll essentially have most of its material absorbed by that galaxy and become subsumed into it.
Scientists believe galaxy mergers are a way of life in the universe. Modern galaxies, including the Milky Way, have grown larger by cannibalizing smaller galaxies.
Every galaxy that we see has probably been through many collisions. The Milky Way has a central bulge of stars, which are probably the relic of a previous collision.
Most scientists agree that the much-anticipated merger between the Milky Way and Andromeda won't happen for at least 3 billion years. But there may be more immediate dangers in space. In cosmic neighborhoods millions of light years away, there are hyperactive galaxies that have become the big bullies on the block. At the heart of some galaxies lives a cosmic monster. It transforms a run-of-the-mill galaxy into one of the brightest and deadliest in space. Quasars are peculiar objects, each powered by a supermassive black hole that continually swallows large amounts of matter, 10 to 20 stars every year.
At the core of these objects lives a very large black hole. And the role of that black hole is to actually generate a huge amount of energy.
Quasars are the most energy-efficient mechanisms in the cosmos. They give off more power than 100 normal galaxies. And they're 10 trillion times brighter than our sun. So how are quasars created in the universe?
There's a fairly good connection between the last stages of a galactic merger and the so-called quasar phenomenon. If that really happens in the case of the Milky Way and Andromeda, we could have, for a period of some tens or possibly even 100 million years, a quasar active in the center of the merged galaxies. And a quasar puts out about 100 times as much energy as a typical galaxy. And if we were actually thrown into an orbit which took us towards the center of the galaxy, we could get very close to that quasar and really get scorched.
The word quasar stands for quasi-stellar radio source, which means star-like emitters of radio waves. The word was coined when the quasar phenomena was still a mystery. Now we know they're not star-like at all. In addition to emitting radio waves and visible light, quasars also give off ultraviolet rays, infrared waves, X-rays, and gamma rays. All deadly if something or someone gets too close.
A quasar is a supermassive black hole at large distance that is active. It's powerful, it's emitting light, and we can observe it in many wave bands.
Quasars were first discovered in the 1960s, but as radio telescope imaging got better, astronomers discovered that some of those quasars also have powerful jets beaming out of them. These particular quasars are called blazars, probably some of the most violent phenomena in the universe.
Blazars are powered by black holes, just like quasars, but they're somewhat different in that all of that energy is being focused, or a large amount of that energy is being focused into jets, which are streaming out.
A blazar's aggressive plasma jets produce radiation in the form of radio waves all the way through the spectrum up to high-energy gamma rays. Astrophysicist Glenn Piner has been investigating the physical conditions at the centers of these exotic galaxies.
We can use this fountain to visualize the geometry of a blazar. If that circular base of the fountain represents the accretion disk, then the jet of water that's coming up represents the jet of plasma coming out from the blazar. And if the Earth is sitting up in the direction that that water is going, then we would see this object as a blazar.
To an astronomer, it's like looking down a fire hose. It really gets you in the eye. You see this bright, blazing thing that we call a blazar.
These blazar jets move exceptionally fast. The fastest observed move at 99.9% the speed of light.
If you were to take a small object like this bowling ball and you wanted to accelerate it up to 99.9% of the speed of light, you would have to give this bowling ball all the energy produced in the world for an entire week to accelerate it to that speed. And in these blazars, we're accelerating not just small objects like bowling balls, but large masses of the mass of the planet Jupiter, or larger, to those speeds. So they're being given incredible amounts of energy by this efficient engine.
Blazars pose unimaginable consequences to cosmic objects that get too close to its deadly jet.
If there was a planet relatively close, a few light years from the actual jet, the radiation on that planet could be millions of times what it gets from the star. It would be continually exposed to high levels of radiation. So I don't think we want to look for life on a planet that would be orbiting a star that's in a blazar jet.
Scientists link radio telescopes all over the world to achieve the magnification needed to zoom in on a blazar jet.
So to give you an analogy for what kind of magnification that is, that would be magnification sufficient to read a newspaper that someone was holding in New York from Los Angeles. We'd love to look as close to the central black hole as possible so we could actually figure out how nature is accelerating these jets and getting them up to such high speeds. And we'd also like to know what it is actually that the jets are made of, because it turns out that's something that's currently not known.
Until more is known about blazars, astronomers will keep a neighborhood watch for them, as well as all the other dangerous places in our uncontrollable universe.
Definitely there are violent events going on in the universe. Much, much more energy than we can even imagine on Earth. There are trillions of suns shining all at once. Those are the kinds of energies that we're talking about. But in that case, the fact that we are far away from them helps the survival of our species. If we're actually traveling through space, then definitely we will have to be worrying about these events.